This video focuses on finding the correlation coefficient using Pearsons. I'm just using Pearson's name for short. All right, what we're going to do is identify this, it's called coefficient determination of r squared. Go ahead and write that down, you're going to hear that later, this definition. All right, I'm just going to read this to you. You'll notice when we find r in the graphing calculator, I haven't showed that to you yet, you'll learn about that in a little while, but I want us to do this by hand. So we're going to use a formula with Pearson's correlation coefficient. That's the long name for it. For short, I'm just going to call it Pearson's. And this is called the coefficient of determination. It tells us the percentage of change in y that is due to x, if and only if there is an explanatory response. So is there a relationship? R does not require an explanatory response, but R does. So I do want you to write down this list right here, the strength of the correlation. So remember we kind of went through and graphed some points, and if we have r squared, so r would be 1, it is a perfect correlation. All the data points make up a pretty line. Then, if you have 0.9 to 1, then it's very strong, and then you see as it moves through, smaller the decimal place, the weaker it gets. If your r squared is 0, means your data points are all over the place, so there's no correlation. Please go ahead and write that box down. All right, here's Pearson's product moment, correlation coefficient R. Pretty long name. So just go ahead and write this down for me. Pearson's correlation coefficient R. Just those words is fine. And then go ahead and write down this formula. Very important. You're going to use it in your assignment. What it does is it finds that R value by hand. And then if you want to, you can write down what all of these things mean, kind of your choice. We're going to do an example together on the next slide. So N represents the number of points you have. The next one, remember that notation that looks like this? This is called sigma. And in math world, that is sum. So the first sigma notation, the sum of x, the sum of all the x values. This one refers to the sum of all the y values. This one refers to the sum of all multiplying of the x and the y values together. This is the sum of x squared, sum of y squared, sum of x all squared, and then the same thing for y. All right. So again, we talked about what r squared means. It's called your coefficient of determination. It represents the proportion or the percentage of relationship between the two variables. The greater the r squared value, the greater you have a relationship between the two variables. All right, we're going to move on to our example. Here's what we're going to try and find. So let's pretend we go out and we survey some students in our class, and we ask for their height and their weight. So we have their height, that's going to be your your x value, and then you have your weight, which is going to be your y value. And you can imagine going out and graphing those points on an xy plane, a coordinate plane. And we want to see, is there a relationship between the height of a person to the weight of the person? So I've listed our survey information here. So we have the height, which is your x, your weight is your y. So the first person here, 167, and then 52. Okay. What we have is a few more columns. We have x squared, y squared, and x times y. So take some time and write down this chart, because you're going to have to do one on your own in your assignments. Okay, hopefully you've got and written down those information. So the first column that we're going to calculate is x squared. So imagine taking 167 and squaring it. When you square it, you get a pretty big number, 27,889. So then you're going to take y and square it. So 52 squared, and you get 2704. Then you're going to multiply these two numbers together. 167 times 52 equals 8,684. Okay, so imagine we go through the next person, the next person, the next person. I'm just going to go ahead and give you these numbers. So we'll pretend we've gone through and calculated them all. You know, calculator's going to be your friend on this problem. So again, we're just squaring the x right now. Okay, and what you want to do with that first column in blue is you want to add them all together. So you get a pretty big number. That's your sum of all of your x squareds in that column. Now we're going to go to the second column and we're going to multiply the y values to itself. Let's pretend we did that, so I'm just going to go ahead and give you the numbers to go a little faster here. Then we took our calculator and added up all those numbers in the red, and that is going to be the sum of your y squared, so 32,661. All right, last column here in the green. Now we're multiplying x times y. All right. Looks like I might have missed one. Oh, nope, I didn't. We put it down here. So now the sum of x times y is 96,238. All right. Before we move on, I want to go back and sum up the x column and the y column. So let's put these in purple here. So we just summed up all of the heights. And then in black, we summed up all of the weights. All right, now we're going to go ahead and figure out the value. So I've done some steps here for you. So calculate the sum of x squared. So we did that. 28,827. That's the sum of all the x squared. We summed up all the y squareds. That's in red. So the sum of that, y squared, is 32,661. And then you would do the same thing for your sum of x, y. Okay, here's the fun part. We get to plug everything into this fun formula right here. So the first thing we want to do is, I'm just going to go ahead and throw my fraction, identify how many points we had. How many people did we go out and survey? That's your n, right there. Well, there was 10 people that we surveyed. Then we're going to multiply it by your sum of x times y. So your sum of your x times y, which is right up here in the green. So 9, 6, 2, 3, 8, minus, and now we're going to multiply the sum of x and the sum of y. So this is this purple one here and this black one there, the sum of those two. Okay, that's the numerator. What fun. Now we go down to the denominator. We have a radical, which is a square root. And we are going to start back with n, which is your number of terms, number of points people you surveyed is 10. Times the sum of x squared. So the sum of x squared, right up here in the blue. Minus the sum of x, and what we get to do is square that number in the purple. All right, run out a little bit of room there, so I'm just gonna kind of write this. There should be more in that parentheses. Now we're going to go ahead and take our n again. That's 10, so we're right here. And then the sum of y squared. So that's up here in the red, 32,661. Minus the sum of y squared. Y, and then we have to square it. So we're taking this black piece right here and squaring it. All right, now let's pretend we went through all the calculations. We're saving ourselves a little bit of time here. And we get a value that looks like this after we've gone through, simplified it, of r, R value of 0.88298. If we want to find the r squared, all we do to find r squared is we take 0.882998 and we square it. And we'll get our correlation coefficient of 0.779685. What this means is you have approximately a 78%. Remember, this is a decimal, so you convert it to a percentage 2 places to the right. It is moderately strong correlation. How did we get that word moderately? Is remember down here, this down here, so 0.7, all right. And that's how you calculate the correlation, the strength of the variables. If you wanted to take some time and graph it out with your graphing calculator and scatter plot it and see that relationship, you could also do so.